Okay, so let's start the webinar. Thank you very much for coming. We'll start webinar now. Yeah, thank you for having us with I think in the last 3 months. Yeah, so we've been doing the webinar every Thursday. Thank you very much still with us up to now. So today we'll be talking about one BGP tuning. And then this time, yeah. So one tips that is very useful for doing your BGP is pairing with loopback IP address or loopback interface. Okay. So let's try. Yeah. So agenda. Oh, I haven't updated this one. Okay, sorry. This will be updated when I upload the slide to the Slideshare. Okay, so these are our agenda. So we'll be talking about BGP and then the pull-up route later. Better if we update the content now before I forgot. Okay, so yeah, for those who are new, we are GLC, Garda Lintas Cakrawala. We are based in Bandung. We do training and IT consulting. We do MikroTik, Ubiquiti, basically networking. We do networking, Linux, and then some programming. Yeah. And then my name is Achmad. I'm based in Bandung. I'm a user of several technologies for like Linux, MikroTik, Ubiquiti, yeah, things like PHP, PostgreSQL, and others. Okay, so if you have LinkedIn, and then we can connect here. Okay. Next is about experience. So mostly our projects were related to ISP. Okay, so we fixed the ISP routing issues, doing the integration with other system, develop a billing software, and so on and so forth. Okay, migration from a routed bridge network to the routed network. Yes, we can do that. And yeah, mainly for ISP. We also do training and then develop software for very custom purpose. Okay, I think some of you are not directly connected to the Zoom. Okay, but that's fine. Thank you very much. And then we assume you already know several topics here, like TCP/IP, routing protocol, BGP, and then others. Okay, so just for review, so we do review to make sure that we are in the same page. Yeah, first, this is very basic. If you are a network engineer, you must have OSI layer. You already know OSI layer, and then the protocol inside is inside layer. So basically, what we learn as a network engineer is the protocols. Okay, so and then based on those layers, we do encapsulation. Yeah, so we are passing data from upper layer here to the lower layer over here. And then on each layer, we are adding information that is called header. So this is the original data we send. And then on layer 4, this is called layer 4. Either it's called segment or datagram. And then this is the data that we have so far. And then on layer 3, this is how it looks like. Okay, it's getting bigger and bigger. And then this is what you see in layer 2. Okay, so this is your data, and then this is what you send. And then this is the process of encapsulation while you are sending something to the network. And decapsulation is the opposite. So you are peeling out the data, right? And yeah, and then you get your original data back. So if you can see, this is the summary of encapsulation, right? So similar to the previous one, but more appropriate. So this is what you send. Okay, one box is equal to 1 byte. And this is what happened in layer 2, layer 4, I mean, this is layer 3, layer 2, and then this is what you send. So if you add more technologies, usually they introduce a new headers like MPLS here. So as you can see, this is what you send, right? And this is, I mean, this is what you type on your WhatsApp, and this is actually what you really send on the network. Yeah, so you can see there is a big overhead in the network. Right, so let's move into the routing things. So we have router and routing. Router is the device, routing is the process, right? So they are doing a processing of the routing based on the layer 3 information, either it's IPv4 or IPv6, right? Here or here. Okay, so this is what you are looking for, right? Here and here. Okay, so on IPv4, it's shorter, only 32 bits. Okay, so we on one header, we have two addresses, either it's source and destination. Yeah, so moving on. So let's talk about the physical physical shape of the network. So here we usually call physical topology. Yeah, so typical connection, physical topology. So it shows you how it connects physically. This router connects to that router through the switch in the middle, and then it's connected to the access point. Access point connect to the end device. That's all. Yeah. So usually we have a physical topology, and then here we have a logical topology, logical connection. Okay. And then in logical topology, what we are focusing on is just network on layer 3. Okay, we're not talking about the switches and then cables. So we're just focusing on this subnet, this prefix connect to that prefix through this router. That's it. Okay, so on every router, we have a routing table like this. And then this is how it works. Yeah. It works like a firewall, match and action, right? So this is the destination, and then here's the gateway. Simple as that. And then here we have the things that is called default gateway, right? Which saying that if there is no match, and then just send them to the default gateway. This is what happened when a packet arrives at router 1. So for example, this is router 1, the one on the left. Okay, yeah, so we will do this exercise later. Okay, so we assume you already know that. And on MikroTik, this is where the routing table lookup happens, yeah, on routing decision. So if you have a firewall, if you see the firewall, we have a pre-routing, and then after that we do a routing decision, which saying that, okay, the packet will be passed or destined to the router itself. Okay, so if it is passing the router, and then means forward, okay, and then after that go to post routing, and then packet is sent out to the output interface. So basically input interface and output interface can be in the same interface. Yeah, it is possible, yes. So if the packet's destined to the router, if you ping to the router itself, we don't use forward. Instead, we will use input or output. Okay. Yeah, as I said, this is how routing works. Okay, so you can imagine routing is like having an intersection of a road. Okay, so you have a road here. Okay. Okay, so either this is you. Okay, you want to go left, you go straight, or you go left, right, or straight. Yeah, and then you see a signboard here. Okay, this is your destination, and then here's the distance, right? And then here's the gateway, right? So same concept here applied to the table here, right? So this is your destination, and then this is your gateway, right? And then here's the distance. So you'll pick a gateway that has shorter distance, right? So for example, you want to go to this network, and then this is the one, this is the entry that you pick. Why? Because of the lowest distance compared to others. So same concept again is applied to the real routing table like this. Okay, so this is the command you can type on your MikroTik. Same tables, right? You have records, and then here are the fields. Okay, either it's destination address, the gateway, or distance. Okay, simple as that. Okay, so this is administrative distance. Depends on the routing protocol itself. Yeah, and then this is how set. This is a static routing. Static routing means you log into every router, and then you type routing by yourself. So you have to log in one by one and then add the routing manually. Okay, so this routing table like this is created manually. Okay, so this kind of table created manually. So you go to router 1, you type manually, you log into router 2, router 3, and so on and so forth. So for a small amount of routers, that's okay. Right, but for a bigger network, no, please don't do that. Yeah, so usually for a bigger network, for the internet, so what we use is dynamic routing. So meaning that you are running a software in every router here. We're running software here, here, and here. And then the software is called routing protocol. Either it's RIP or SPF or BGP or ISIS or EIGRP or whatever. Okay. Yeah. And then we talk about routing metrics. Yeah. So for example, when we decide the best path, there is a value used by router to make a routing decision, and then that value is called metric. Well, metric for every routing protocol is different. Okay, so for example, OSPF is accumulated cost from host to destination, from source to destination. Okay, RIP is using hop count. So accumulated cost means interface at the interface. So we have an interface. Every interface has its own cost, so it's accumulated from source to the destination. ISIS is using cost. EIGRP also cost, but consists of this a combination of these parameters. Okay, so EIGRP is aware of bandwidth, load, delay, reliability, and MTU. BGP also has metrics, and this one is quite complex. First is AS path, next hop, origin, local preference, atomic aggregate, and MED. We'll be talking about the here we call it the attributes. Okay, in the future, because it's too many parameters if we talk all of them in one meeting. And then we need to know that actually routing is this asymmetric. Okay, so inbound path and outbound path are not similar. Okay, so this is outgoing, okay, but this is for incoming, right? So there is no guarantee that incoming path is similar to the outgoing path. So the things that we can only control is outgoing. So we can only make sure the outbound is exactly working as what we are expecting. Right, so let's talk about BGP. So BGP, again, is a dynamic routing protocol, path vector. It's different to OSPF that is using link state, okay? So this is, again, path vector, okay? So, and then they are connecting AS number. So every router needs to create BGP peer working on layer 5, session layer. So it uses BGP peer session, okay? And then on layer 4, yes, it's working on layer 4 as well. TCP port 179, used by all routers in the internet. And then the routes content can be full routes or partial routes, okay, specific prefix, okay. So if you want to be a part of the internet, you must have an AS number. You must apply a prefix to RIR, okay. So yeah, if you are a kind of organization, well, several things to consider. You need knowledge, okay. It's not like, oh, okay, I'm part of the internet. I have AS number, I have prefix, and then I just connect to the internet. No, you have to configure your BGP. Okay. Yeah, yeah, I have clients here. They are also have AS number, and then yeah, some of my tasks were to optimize their routing. Okay, so yeah, I log into their routers and then fix here and there. Yeah, so as I said, this is autonomous system, autonomous number, AS, okay. So it's a collection, AS is collection routers and network, okay, under one administrator defined by AS number, okay. So you get this AS number from IANA. IANA delegates to RIR, IIR delegates to the regional RIR. This is for Asia Pacific, this is for Latin America, this is for Africa, this is for North America, this is for Europe. Okay, so if you are located in one of them, I'm not sure if there is a South Pole or North Pole, to which RR they have to contact. Not sure. So we are in Indonesia. So we are calling Epinik, so saying that, okay, hello Epinik, I want to apply for AS number and prefix. Okay. And then you have your own AS, and then we run BGP between AS. Okay. And then inside AS, we run IGP, Interior Gateway Protocol. BGP is Border Gateway Protocol. So for example, this is IS number 4. Okay, so you run BGP here. So this is BGP, this is BGP. Okay, and then what about this router 1 here? And then we can run IGP. Okay, so Interior Gateway Protocol, for example, OSPF, 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 OSPF. So what about the border router here? They're running OSPF as well. So at the border router, they're running two routing protocols, BGP and IGP. Okay. So BGP to connect to the internet, IGP is to connect to the internal here, internal organization. All right. So how BGP works? Okay, set up router ID. Usually this is done automatically in MikroTik, and then create BGP peer. This one is very important. Yeah, it's very mandatory for router OS 7. Okay, you have to create inbound and then outbound. And then you can exchange routing table between routes, and then the routing BGP routers will keep alive periodically to make sure that my partner, my peer, is up. As I said, when we talk about routing protocol, there is a metric here. Yeah, as a BGP has here. Okay, so this the metric. For BGP, the metrics it has several parameters. Yeah, and then all parameters are classified like this. Okay. So mandatory, discretionary, so well-known, WK. Yeah, as path, next hop, origin, okay, local preference, atomic aggregate. Yeah, it's not always exist. Yeah, so, but for mandatory, it must exist. And this is optional, okay. Transitive is not recognized, make it partial or, and still propagate it to network, to the neighbor, okay. for example, community or aggregator. Yeah, so these are the information, okay, and then based on those parameters, here is the algorithm. So first is check is route is valid, selecting the best path, and then check the highest weight, and then check the highest local preference. Yeah, because in internet, at the internet, you will get the same prefix from several peers. Okay, they are telling that, okay, if you want to go to this prefix, you can go through me. Okay, especially if you have more than one, you have many peers. Okay, yeah, they will tell you that. Okay, that's what happened. Okay, yeah. And then it is your router who decides this is the path that I pick. Okay, so and then here's are the criteria if you are using MikroTik. Well, not only MikroTik, common router is doing the same as well. Okay, originally, origins, and so on and so forth. You can see the list by yourself. Okay, so let's do BGP peering. Yeah, in this networks, so we have AS86 connected to this. So you can think this is like IXP, Internet Exchange Point, okay? And then all of them are AS number, okay? So this is AS number, and then these are the prefix that they are using. Okay, so 19, 17, 15, 20, 13, and 11. Okay. And then, so as you can see, this is AS11. They have a border router here and here. Okay, AS13 border router, ASBR, okay, AS border router. Okay, so what we will do is we need to connect router 2 and router 22 using a loopback address. Okay, so actually, when you do peering, you can do peering with the IP address that is assigned to the physical interface like this. Yeah, so as you can see, this is E2, yeah, Ethernet 2, right? Yeah, so on Ethernet, at Ethernet 2, you put an IP address there, right? And then you can use that IP address for BGP peering. Yes, it is possible. But there is also alternative that inside here, router 21, 22, inside there is a loopback address, and then you can put IP address there. So it means that our peering will done between the peer, or will be done using the loopback IP address here. Okay, so it's not using physical interface anymore, but we can use loopback address. Okay, so I draw again. So this is normal or traditional peering. Okay, this IP connected this IP, okay, with the physical interface. But alternative is we can use this loopback IP here and here. Okay, so how to set up BGP peer is very easy. Yeah, so in router 6, you set up peering. This is your local AS number, and then you inform that AFI address family. What is I? I forgot the I. And then you put here your router ID. It has to be unique in the network. Okay. Remote address. Okay. Remote address. Remote AS. Here's the local address, and then here's the type. Okay. So if it is external BGP, which connects between what is it? AS, and then you pick here BGP. If it is inside one AS number, and then it's called iBGP. Okay, so that's what you configure on General tab. And what you need to do is a filter. Click here, filter. You can see it here, filter, and then you put here BGP filter, either is input or output, and then you also put the BGP prefix, the prefix that you want to announce to the to your peer. Okay, so this is BGP input like this, and this is BGP output like this. Okay, so this is very new, very different compared to version 6. Yeah, because as a default, default action is reject. Okay, so you have to create, okay, you have to specify which prefix that you allow for your BGP. Okay, you can use destination here and destination length. Okay, here's the length of the prefix, and then here's the prefix itself. Okay. Forgot. Okay, now this is our main menu today. So why we use loopback? Yes, best practice, use loopback. Why? Well, very simple. Because loopback interface is virtual, and because it's virtual, it's always on. Okay. So because it's virtual, therefore it's agnostic to physical status. Okay. So this is virtual. Virtual antonym of virtual is physical. Yeah. So nothing to do with the physical. If an interface is broken, no problem. It's always virtual. Okay, and it's also resistant to topology change, of course, with the help of IGP. This is very helpful for internal BGP peering, but actually eBGP, external BGP, can be used, configured to use loopback address here. Okay, let's discuss with the topology. Oops. Yeah, so this concept you can apply with other routers, Juniper, Cisco, you name it, right? So for example, if your peer is between this and this is your peer, okay? What happens if ether 3 is down, and then your peer is down, it's stopped, okay? But if you do peering here and here with the loopback address, this loopback address is nothing to do with the physical interface. Because IGP, for example, OSPF, they can have a direct route here. They can have direct route. They can have indirect route through here. They can have indirect route through here. So if, let's say, this one is broken, and then you can still have your own peer, right, through this link. Okay, of course, again, with the help of IGP. So make sure before you run, if you use loopback address, make sure your IGP is running. Okay, so it's very simple. So only that. Okay. Yeah, that's the reason why you should use a loopback address for BGP. And then how to do peering with loopback is very simple. So on loopback, okay. Yeah, so make sure loopback addresses are reachable. Okay. So for example, through IGP, yeah, you can set up RIP, you can set up OSPF, static route, whatever. So make sure this loopback address is reachable without BGP intervention. Okay, without IGP, you should be able to contact them. Okay, and the next is we can use loopback address as a source address, as simple as that. So the address that you type here is your loopback address, as simple as that. Okay, in the previous version 6, you have to define from which interface you are sending your advertisement to, your advertisement from. Okay, so for example, I do peering with loopback interface or Ether 1 or Ether 2 or whatever. Okay, but here you can just choose loopback address. Okay, so I think that's all. Yeah, so this is the main things for today. Yeah, hope you enjoyed. Yeah, for question answer, if you have question, and then type here, or you can just ping me in our email or WhatsApp. Okay, so if you're interested, just come to our training. Inform our admin that you would like to join our training. Okay, this is the end of the slide. Okay, so if you have feedback, you can type your feedback here. Further events is available on our website. Yeah, Facebook, we have that. Slide will be available on Slideshare. Discord is available in Bahasa Indonesia. Recording will be uploaded into YouTube. Okay. Or perhaps you can do some demo here. Oops.
Hello, Mr. Ahmad.
Hello.
Thank you for your presentation. That's amazing.
Thank you.
Yeah, I'm
Okay.
Agus.
Do you?
Your junior.
Oh, Agus. Oh, okay. I thought
Yeah,
somebody else.
GLC
Yeah.
warrior.
Oh,
Yeah.
yeah.
Yeah, I have one questions about your
Uh-huh.
presents.
Presentation.
Your presentation.
Okay.
You say that you have client using BGP and then
Yeah.
you optimize routing, right?
Yeah.
Yeah.
Yes, correct.
I interested
You are
how
interested?
to,
Okay.
yeah, I interested about the topics, how to do
Well,
that.
the topic is loopback at the moment,
But
not
I'm
something else.
not interested. Yeah. Yeah, I
Okay.
think loopbacks in BGP and other thing
Uh-huh.
metric parameter is commons.
Yeah. Uh-huh. Yeah,
Yeah,
that's the
that's the
default
points.
knowledge that you need to have if you want to apply BGP on your network.
Yeah, it's mandatory.
Yeah. Okay.
Okay, that gets the point about my questions.
Yeah.
How to do that? You optimize routing. I mean, parameter or classify routing on an IP address or others. Optimize in routing. How to do that?
Yeah. Usually, yes. Usually, what happen is, okay, maybe it is much more better if I draw something here.
Okay.
Yeah, for example, my client has a router. Okay, so this is the router. Okay, this is their router. And then they have lots of, actually, maybe 5 or 6 even. They have the peering here, peering here, peering here, peering here, peering here. Can you see the screen?
Yeah, I can see
Okay,
the
and then
screens.
here's their own client, yeah? Client 1, client 2, client 3, okay, here, and here, okay? So this is peer 1, peer 2, peer 3, peer 4. Yes, you can imagine peer 5. Okay, so sometimes they said, okay, I want to do incoming from here, but outgoing from there for particular things, yeah? So that kind of things. So they expect traffic should be coming from here, but why the incoming is from here? Understand?
Yeah.
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 Okay. Yeah. So that's one case of optimization. And then for doing that, yeah. So I asked them what kind of policy that you want to do. What kind of expectation you want to make with that peer? Oh, okay. And then so we asked them, okay, so I want to set up if incoming traffic, if it is incoming traffic, should be coming from here. For outgoing traffic, for Google, go this way. For Netflix, goes that way, and so on and so forth.
Okay.
Yeah.
So BGP
So
that is using eBGP, right? External BGP, not
yes,
iBGP.
external BGP. Yeah. So and then for that one, for those in optimization, we'll be playing a lot with route filter. Okay.
Oh, yeah. Okay.
Yeah, route filter is very, very important here. So for example, Netflix goes this way. Okay, Facebook goes this way. Google goes this way. Right?
Yeah.
Yeah, so
So
that's one
we
example
can,
of routing
mm,
optimization.
yeah. So we
Yeah.
can use parameter like AS path or
As
max
path,
swap.
yes. Yeah, we need to know yeah, the parameter for doing that.
Okay, right.
Yeah, because every organization in this planet, in the world, must have an AS number. And then we
Yeah.
need to know, of course, we will know Google AS number,
Okay.
Facebook AS number. And then based on that, we can tuning our prefix, our routing. Yeah. And then, as I said, we can only control outgoing traffic. Okay, so for outgoing, we can do that. But for incoming, we cannot always control because that's not our responsibility.
Okay. Yeah. So
Right.
based on my perspective, is similar with Mangle in MikroTik, right? So yeah,
Mangle.
yeah,
But this is
like Mangle.
for this is on internet level.
Internet level. Okay, right.
Yeah.
Okay. Nice, Mr.
Yes.
Ahmad. I think it's
Yes.
enough. Thank you
uh,
for everything.
yeah, you're welcome. You're welcome. Well,
Okay.
if there is no questions, I think it's time to photo session. Yeah. If you don't mind, you can
Okay.
turn on your camera and then we'll take a picture together here. Yeah, it's been so long. Where have you been? Huh?
I have been somewhere
Still
place.
in Bandung? Going somewhere?
Somewhere place.
Oh, okay. Right. Okay. Yeah, let me take a picture together with the slides. Okay, let me prepare. So the interface here is quite different now. Zoom. I need to find out where the menu is. Oh, okay, here it is. Should we put the... Oh yeah, here's the camera. All right, so, okay, let's take a picture. One, 1, 2, and 3. Okay, thumbs up. 1, 2, and 3. Yes. Thank you very much, Agus. Yeah,
Okay,
very
thank
nice to
you,
meet you
Mr.
here.
Ahmad.
Oops.
Yeah. Can I request the topics for the next
Oh,
webinar
yeah, we
or
can discuss it here. Yeah, I think it's a good idea.
maybe I don't know in MikroTik
Oh, you can
support?
be, why don't we just set up a collaboration webinar?
No,
Yeah.
I'm not confident, Mr. Ahmad. I'm still learning.
Yeah,
I'm
I'm
not
learning
confident.
too.
Yeah.
Yeah, we are learning too.
Yeah.
So
Can
it's up to
you
you.
have a topic? Okay. Can you have topic about MPBGP? Right.
Sorry?
MPBGP. MPBGP.
MP
Yeah.
BGP. What is it? MP
Mo
BGP.
yeah. Multi-protocol BGP.
Oh, what's that about?
About
Like what?
MPLS.
Oh,
MPLS and
MPLS with BGP. Oh, yeah, but it's
yeah,
not.
multi-protocol to
Yeah, you can
carrier.
run. Yeah, but actually, it's a very very complex implementation. So
It's very
first,
nice.
no, just make your networks more complex. I don't recommend to use it. Yes, we
Okay.
implement it. Yes, in Africa,
Okay.
yeah, but I don't recommend it. First, you have to run OSPF, and then
Okay.
on top of that, you have to run MPLS,
MPLS
and then
LTP,
on
right?
top of that, you run the BGP. So
MPBGP,
it's like
yeah.
a
And then
BGP
L3 or
signaling for
L2.
creating.
Yeah,
Yeah,
okay.
it's up to you. Yeah, you can run layer 3. So it's like, you know, why make your why do you want to make your network so complex that is hard to manage while nobody is using that service, right? Yeah,
Mm,
you can say BGP signaling VPLS. Yes, you can use it. It's very nice. You don't have to create it manually, but how many customers willing to pay for that? Instead, you can
mm,
use UIP for creating a tunnel. And then
mm.
that's not everyday job. You can do it
Okay.
once a month. Yeah, but we
Okay.
can do it. But for implementation, I don't think so. It's working in version 6, yes. But for version 4, MPLS is not. I
Okay.
don't think it is ready yet. Okay, for
Okay.
BGP is very good, yeah, in version 7. And then we use a lot BGP with version 7 in most of my clients, but there is one my clients, I urge him to upgrade to version 7. But they say, oh, no, do it later. Okay, I'm not confident with that.
Okay,
Yeah,
right. Okay,
yeah,
no
yeah.
worries.
Yeah, there is
No
only
worries.
one, but other clients, they just use version 7 right away. But
Yeah.
they got very shocked because the way you implement the routing filter in version 7 is completely different
Yeah,
compared
yeah.
to version 6. Yeah, so it's more on programming on version 7, but it's very flexible. It's very flexible, but you have to upgrade your knowledge,
Yeah,
especially
yeah.
if you know regex, regular expressions. Yeah, that is very very useful if for upgrading the um, for creating the filter. Yeah. Okay,
Okay.
but that's is good. Yeah, MP BGP. Yeah, it's MPLS with BGP signaling. Yeah, you just make your life difficult. Yeah, difficult to manage.
Yeah,
Oh,
yeah,
yeah,
yeah.
yeah. And then when you
Okay.
hand over to the other engineers, not that easy. For version
Okay.
6 is okay. Yeah, but it's a good topic. Yeah, that shows you're doing here and there. Yeah, you can do social climbing with that. Pansos,
Uh,
yeah.
yeah, it's
MPVGP, MPVGP. I
yeah,
can do
it's the
MPVGP.
last
What in
technology. Yeah, it's the last technology update.
latest technology? I don't think so.
It's
MPLS has been run for many years.
yeah for MPLS, but for MBBGP, any other thing like now there are segment routing,
A
segment
segment routing.
routing. Yeah,
Yeah, yeah. But I don't think it's been implemented.
BPLS,
Yeah.
VP, VP, double S, WS. That, that many things the
Yeah.
update.
Yeah. The question is, you have many jargons that you just said. Okay, segment routing, whatever. And then why don't you just implement SDN? You can program it by yourself,
Mm,
right?
yeah,
With with uh, with uh, with SDN, you can do whatever you like.
yeah, 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 yeah.
Yeah,
Right.
what you
Yeah.
need to do is just a switch. that is capable of doing SDN.
Yeah.
And then you can connect to the switch and then use their API, and then you implement your own rules.
Yeah.
It's very much more simpler compared to the things that you just said. Besides, for those big vendor, again, yeah, my clients are middle company, mid-level company, a small medium enterprise, and then I don't think they will. They have a thought to buy things like Cisco because it's very expensive, and then besides, they don't. Many organizations do not need those kind of functions like segment routing, whatever.
Yeah.
But for Pansos, perhaps you can do that.
Yeah.
For social climbing, yeah. I mean, industry is not like that. No, they're just
Okay.
making money with the cheapest equipment possible. Yeah.
Yeah,
Yeah.
it's
Why don't you
great.
just implement segment routing, MP, BGP? Well, you can just make money with current things that you already have.
No,
Why don't you make yourself difficult?
it's not
unless,
recommended.
unless, yeah, unless, yeah, this is, I mean, I come to this conclusion based on my experience, right?
Yeah.
Based on my experience, I was working in industry since 2004, 2005. Was working in a big company, middle company, and then I ran my own consultation organizations. I met many clients in Indonesia, in Malaysia, in Africa, in UK. Well, why don't why do you make yourself difficult by implementing the things that is difficult to troubleshoot, right?
Yeah.
Yeah.
Okay.
But for Pansos, it's okay lah.
Yeah, I
For
think we need to
social
pan
climbing,
sauce. Yeah, we need to pan sauce
yeah. But
for
it's
branding.
it's yeah. But again, yeah. Perhaps we can do we can implement it. Yeah.
Okay.
Even though practically, I don't think people will use it. Nah. Okay,
Okay.
anything else than MPBGP, segment routing?
I don't know.
Okay, what else? So what have you
Yeah.
been doing lately? Perhaps we can talk about that.
No, I have no
Is there
idea.
any project you have done lately?
No. I'm
No,
still
no
learning.
projects?
No.
Yeah, what you have learned so far, then you can share, right?
Ah,
Doesn't have you from your clients. And then I don't
mm.
want to show my client's router here. No, it's
Yes,
private, yeah, and
perfect. Yeah.
confidential. No.
For
Anything else?
no.
Come on, you must
It's
have a lot, yeah?
it's enough, Mr. Ahmad.
Huh? Oh, okay.
Enough.
Well, actually, uh, we have three actually. We do networking, system administration, and programming. So the topic is not always networking. If you have other topics related to system administration, that is Linux based or whatever, we can talk about the file system, web server, load balancing, whatever. Or if you want to share a programming stuff like PHP, Python, or whatever, we can make it happen. Yeah,
Yeah.
we do. Yeah,
I
because
need more time. I
and the
need more
time.
time.
Okay. Yeah. Because here, when I got the call from my clients, they said, okay, in the beginning they talk about MikroTik, and then they also have a Linux server, so we do Linux as well. Okay, and then okay, what happened if we want to make your organization better. Okay, make your system better. Okay, and then we introduce them programming. Okay, so we create the custom software, web-based application. So we develop yeah, web-based application for billing, for example. We develop that. So I myself has to do SQL query to a database, setting up billing, send billing through email every, for example, 24th of the month. Yeah, things like that. So I'm not limiting myself only for networking, because IT is too wide, and then customer actually do not need networking; they just need solution.
Yeah.
Right.
Yeah.
So, and solution can be a combination of networking, system admin, and then programming.
Yeah.
And then from my experience, it's quite hard to develop a programmer compared to sysadmin or network admin. For network admin, I can teach you this, and this easily, as long as they have a good logic.
Yeah.
But for programming, it's a different things. Because there are so many things that you need to learn. You need to learn HTML, CSS, JavaScript, PHP for programming, and then you have to connect the programming to database. And then you have to do something with the database, either insert, delete, or creating a report. You have to make a view. If it is more advanced, you have to create functions. So we put the functions into the database instead of the programming. So because if we replace the programming, the logic is still there in the database. Right, you can set up a trigger. Okay, so if somebody put something into the database, and then the database will do a trigger by doing calculations and then adding something into the tables, for example. Yeah, it's interesting to work in IT.
Yeah, very interesting.
Yeah.
How about the Pythons? How about Python's programming?
Pythons, yes, we do Python. We use for automation, but in our case, we make it simple. We can create a bash script and then send something to the microtik, execute this, and then run the script. It's done. And then the script we are using is not based on Python. It's based on the microtik scripting itself. So we create scripting, but based on the microtik scripting. Yeah. Well, I think that's all. Yeah, it's time to do other things. Thank you very much for coming, Agus. Yeah.
Thank you, Mr. Ahmad.
Yeah, it was a very good topic. Thank you very much for your recommendation. We'll talk. We'll think about that later. Yeah. Well, again, thank you very much, and then see you in the next webinar. Perhaps we can have a discussion for a collaboration, talking about topics. Yeah.
Okay.
In the future. Yeah.
Okay.
Yeah, we can do it later. Yeah, for those plans. Again, thank you very much, and have a nice day. For those who are celebrating Christmas, happy Christmas, and then see you later. Have a nice weekend. Yeah, thank you very much. Goodbye.
Thank you. Thank you.